All right, this is session 10.2, plane curves and parametric equations. Now we're gonna switch to a completely different view of how we describe a graph using a formula. Anything or everything that we learn up to this point, we often have a functions where you have, right, f of x equal 2x squared minus 3x plus 9, and that describe a parabola. When you graph, it's gonna look something like this. Or we describe it using an equation. So the one that we've learned in the past, in 10.1, look more like an equation, right? You have x and y together form an equations, and this describe a ellipse. Okay. Now now we're gonna call them Cartesian equations. Okay. Cartesian equation, or sometimes rectangular equation. It's just because our equation x and y, when we define based on the x and y coordinate system or the Cartesian plane. Okay. Now, when we have graph, that's a bit complicated. Okay, so when you have graph that is complicated, and I can make it as complicated as I want. All right, so that one, when you're gonna use, when we're gonna try to use x and y in like an equation here to describe it, it's really difficult. Okay, for once. And the second is when we want to describe the graph, not just the graph, like a static graph. We would describe it as a motion. All right, so let's say here's the graph where we start here, the beginning point, and then it's gonna move in these directions. Okay, so if we care about the directions, then we're gonna have to have a different way to describe the motion, and that is called the parametric equations. Now, if you look at this quick example right here, where the graph is look like that, the way we define or to define or describe this graph is by two equations here. I have x equal t plus sine of 2t and y equal t plus 2 cosine of 2t. So this will produce a set of equations, x in terms of t and y in terms of t. So what happened is x and y is still the x and y coordinates of the point, but we introduce a third variable here is t. Often we use t because it stands for time. And for example, if you see both are depends on t. So we have to start out with t. So let's say t equals 0, and then you plug in, say plug in here, you would get what the x equals 0 plus sine of 0, sine of 0, 0, so x is 0. And then you can have the y, and you plug in 0, and you have 0 plus 2 cosine of 0. And cosine of 0 is 1, so this becomes 2. So if t equals 0, then x is 0 and y is 2. So we locate the point 0, 2, which is there, right? So there. And then so on, you're going to plug in t equal 1 and t equal 2, and then you're going to find the locations of that point. It's going to be, so you're going to go to those points, and then it's going to end up with a motion, right? So formally, parametric equations. There are times when we need to describe motions or a curve that is not the functions, like this. We can do this by writing equation for the x and y coordinates in terms of a third variable. Usually we use t or we use theta. We use theta because it's kind of the angle that involves matrix functions. So either t or theta. So we're going to have two formula. One for x is f of t. One for y is the function g of t. So these are called parametric equation, plural form, because we need two equations. One for x, one for y. Now t again is called the parameter. It is an independent variable. Now in the case like this, both x and y are now dependent variables. Okay, so when it comes to plotting points, instead of over here you plug in values for x to calculate the corresponding y, that we often say we use the T chart, right? So if you want to calculate and figure out the x and y, you have the table with x and y, is independent variable, plug in, you got the corresponding y. In parametric equations form, it's a bit different because now you need three columns. We have three variables, right? So one is t, and is x, and is y. So you need three columns. And the independent variable is t, so you can plug in 0, 1, 2, and you plug into formula, calculate the x and the y. Okay. Now, let's look at these examples. Number one here, sketch the curve defined by the parametric equations. All right, so number one, we have x equal 3 minus t and y equal 2t minus 3. So I'm doing example one. I often like to write it in, or sometimes write it in line, right? To save space. But otherwise, you're going to see people put the parametric equation as a set of two equations. X is 3 minus t, and y is 2t minus 3, like that. And in this case, the conditions of t, so there's restrictions of t, t can only go from -1 to +4. Right? Now, then to do that, we will draw, okay, we're going to do the table with 3 columns, and this time, right, so instead of 2, we're going to have 3 columns. Right. Now, what we're gonna do is we're gonna plug in some values for t, right? So this column is t, that one is an x, and that is the y. Now, normally t could be anything, but here you restrict from -1 to 4. So naturally, you're gonna choose -1, 0, 1, 2, 3, 4. Notice that it doesn't have to be integers, but we're going to pick the integers because it's easy to do the math, but it could be 2.5 and anything, right? So if we have trig functions, I would probably pick pi half and pi third, so those are easy to calculate. But since we don't have the trig functions involved, we're going to go with just the integers. Okay, so let's plug in. Again, I plug into where? Here's an x, right? So I plug into this formula first. If t is -1, we have 3 minus -1, that is 4. Plug 0 in, 3 minus 0, I got 3. Plug 1 in, 3 minus 1 is 2. 2 in, 3 minus 2 is 1, and so on. Likewise, for the y function, this is the second formula down here, and you plug in -1. Okay, so I can do it quickly on the side. For the y, they're going to be 2 times -1 minus 3, and -2 minus 3, I think got -5, so that is -5 for y. And if you plug in 0, I think that one it's easy. 2 times 0 minus 3, it's -3. So that is that. And then you plug in what? 2 times 2 minus 3. 4 minus 3 is 1. Oh, sorry. Not the 2. All right, so I'm going to skip that one since I plug in 2, which is the t is 2. So the 1 will be here. Now, if you plug in 1, y equal 2 times 1 minus 3, got -1. So it will be there, and so on. I think I see the pattern. It looks like it's down. Up 2 units, 2 units, 2 units. I think that would be 3, and that will be 5. So don't forget that when you've done this, the t is really the time of independent variables, independent values. So when you plot points, you actually plot the x and the y before -5. So that is the point 1. 3, -3 is second point. 2, -1 is the third. 1, 1 is the fourth. 0, 3 is the fifth, and -1, 5. Right? So we're going to plot these points. So I have the xy plane drawn. Okay. And let me start plotting the first point. I think I did it over here. 4, -5 is this point. The second one is 3, -3. So 3, -3 is this point. The third one is 2, -1. Okay, 2 and -1 is here. And then we have 1, 1 is this point. And 0, 3, this point. And finally, -1, 5. -1, 5 is right on this number. And so be there. Now, as you can see, the t restricted from -1 to 4. So when t equal -1, we are at this point down here. And the last point we stop is when t equal 4. So if you connect the dots, you can see we actually end up with a straight line. Okay, but it's not a straight line though. It's not a line. It's just the line segments in this case, because we are only allow t between the two, the -1 and 4, and then we're gonna have this line over here, the line segment, starting at 4, -5, ending at -1, 5. 4, -5, and -1, +5. Right, so that is the graph. And again, we are able to tell the direction is go it's actually going this direction here, right? Now let's look at the second example down here. The second example, we have x equal t squared and y equal t plus 1, right? So example 2, number 2. For number 2, x is t squared and y is t plus 1. Okay. I actually have the graph drawn ready, but again, so what I'm going to do is we will construct the table. Okay, we construct the table. And when we construct the table, we start with the t. But again, the table here should have 3 columns. So let's say here, and then we have the first column, second column, and third. Okay, so okay, like that. All right, so the t come first. Okay, the t's come first, then the x and the y. All right, t. This time t has no restriction, so the domain is all real numbers. So t could be anything from negative to positive infinity. But we often pick the numbers that are around 0. So something like -3, -2, -1, 0, 1, 2, 3. You can pick more if you like. And then you're gonna plug in here. You see that when x equals t squared, basically the x is just the t value squared. So you should get 9410149. And then for the y, it's actually easy too. It drew the t values plus 1. So if you add 1, it'll become a -2. It's -1, 0, 1, 2, 3, and 4. And again, that will give you the points on the xy plane that you can plot. 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, and 4, 3. And then finally is 9, 4. So you're going to plot these on the XY plane. I actually have the graph inside. You see the 9, -2 is this point. 4, -1 is that. Then 1, 0, 0, 1, 1, 2, 4, 3, and 9, 4. And the corresponding t values are also written there. So in this case, you can see that if you plot the points, it really follows this path. It's really a parabola, open sideways, and it's go in the directions here. Okay, so when you plot the graph, the parametric equation, be sure to draw an arrow to indicate the motions which way it's go. Okay. Now, one thing you can see is since we are unfamiliar with the parametric equations, by looking at these two sets, you have no way to know what the graph would look like, right? So one way we could do is we will convert the parametric equation back to our normal equations. Again, we will call the Cartesian equations, so that we can identify the graphs. Okay, so if you look at this one, for example, I can eliminate the independent variable and put it back in the equation, in one equation. So how would we do that? Normally, the way we do is we're going to pick one equation and solve for t. And then we do a quick substitutions. Right? So for example, here, I'm going to pick an equation, say 1. I think the second equation I like it better because it's easy to solve for t. If you solve the second equation for t, subtract 1, right? So you got y minus 1 is t. Now, if t is y minus 1, I'm going to plug it into the first equation. The first equation is x equal t squared. But t, I can replace it by y minus 1 squared. So you see that I end up with these equations. Or if we flip them, it is y minus 1 squared equal x. Now, if you're looking at this, hopefully you have a bit of memory. What is the graph of these equations? It is a parabola, right? I think this is fit one of the form. We have y minus k squared equal 4p times x minus h. Remember that one? The conic section, that is the parabola. And I do know the h and k. In fact, you see the h is none. So the h is 0 and then the k is 1. So the vertex has to be at 0, 1. You see it's over here. Right? So we're going to learn how to do that by converting from parametric equation to Cartesian equation.